rotation is called flexion. See, he is going forward, that is called flexion. He is going backward, that is called as a extension. If you see here, this is a bending. With respect to this is the left side bending and right side bending. These are the two type of the bending which is over. Then axial rotation with respect to the left and the right. That are the main three which we should know. And coming to the next one. Now, loads acting on the spine. What are the different loads acting on the cervical spine and the lumbar spine? Yeah, we cannot tell in that thoracic spine. The reason is thoracic spine is also supported by the rib cage. Complete rib cage is coming with us, so that evaluation of the forces is a little bit complicated study to evaluate the forces and the loads acting in the thoracic spine. Okay. Next one is the loads in the cervical spine, head weight. For example, cervical, as I told you, it is at the topmost of the knee. It is the one which is holding the head. So there it will be a head weight will be there. Then tension of the spinal ligament and the spinal muscles. These are the two loads. Any external load carried above the head. For example, if I am carrying some weight over my head, that also will be included in the load which is going to act over the spine. If I am taking some weight and I am keeping it in my head, that discs and the vertebrae will face the weight which is being applied from the top of our head. The next one is the load acting on the lumbar spine. The load, as it is at the bottom, which I told you before, so it will take the entire body weight. It will take the entire body weight and tension in the spinal ligament and the spinal muscles. All the vertebrae will be having the ligaments that I will show later, and any external load carried in the hands. For example, if you are carrying some of the loads, that also will accommodate in that spine only. Now to loads acting on the lumbar spine. Now we can categorize the loads into different category. Physiological loads under the normal activity are short-term loads, long-term loads, repeated or cyclic, dynamic load. These are the major different category of the loads. Short-term loads are which are in flexion and extension. For example, if I move my head forward and backward, that is a short-term load. I cannot give for long time over that. Next is the long-term in sitting and standing. For example, if I am standing, that is the long-term load. For if I am sitting, if I am sitting or standing constantly, I will be in the same position for some time. That is called as a long time load. Next one is called repeated or cyclic load. Gait or walking, repeated load. Every second, the different type of load it will take place. That is repeated load. That is called as a gait and walk. We can face that cyclic loads. Next one is called the dynamic loads. Dynamic loads are it will happen when we are running or jumping. These two are the major things while we are running. Dynamic load with respect to that, and jumping, sudden load, that is a dynamic load. And after that, traumatic loads, sudden accidents with great amplitude impact. Where this traumatic load, for example, somebody are driving a car. Sometimes that car is going for a collision. What they will do, the seat, belt which we are wearing can only protect our body from movement, but our head will move forward. That is called as a whiplash. Because of that, our cervical spine will go for a collapse, or it can go for a fracture also. That is called as a whiplash. Due to the sudden impact, sudden break, sudden accident, at the time that part will break. Because of that, the persons may die. That is called as a traumatic loads. Next, loads can be classified from the origin: gravity of the muscles, gravity load, muscle load, and ergonomic loads. These are the major different types of loads based for the muscles and the remaining things. Next, the internal forces. For example, force acting on the spine, compressive normal force, are in laying posture. Different types of postures. What are the forces? Spine can be seen. The spine can be seen. Laying posture, 150 Newton to 250 Newton. If I am standing, at the time the full force it will act over the spine, that is 500 Newton to 800 Newton. If I am sitting, 700 Newton to 1000 Newton. For example, the force in the disc, force on the disc will be around 350 Newton. Next, the shear force, it will take place, that is around 200 Newton. These are the different forces, and afterward tensile force. Now, moment if I am taking the moment, for example, flexion and extension are done with respect to the moment. Okay, so in the moment, what it will happen, for example, what is the maximum moment a spine can carry is, for example, the cervical spine, the maximum it can, for testing level we are taking it as 1 Newton meter, and after that for a lumbar spine we are taking it as 10 Newton meter. The maximum failure is for cervical spine we can take it as 2 or 3 Newton meter, and for lumbar spine as 15 Newton meter. So 10 Newton meter bending while we are lifting up 100 Newton weight with bent knees. That is the 10 Newton meter we are lifting the load. Next 90 Newton meter bending when we are lifting 100 Newton weight with straight knees. With straight knees, that is around 19 Newton meter. For example, some in vivo studies also conducted there. In the in vivo studies, torque can be, that is what I told before, torque causing damage may be around 15 to 30 Newton meter. So safety limit is we can operate inside this limit 6 to 12 Newton meters. Now these mechanical studies where it is being used. Now if you are calculating these forces, this moment, this torque generated over there, these plays a major role for creating the artificial disc and the implants. For example, if somebody is going for artificial disc, implants, screw, plates and rods, now they should know how much forces your spine is taking. If they know how much forces the spine is taking, based on that they can create their implants and the remaining things. So here only these forces, while we are numerically telling some of the things, that is where the starting point of the biomechanics. These are the calculated ranges. These ranges will help the surgeon to decide the surgical part. Now what we are using these forces, if I am creating a finite element model or something, I can simulate the study and see. Experimentally I can conduct the study, and after that I can use the finite element study as well as to find out how the forces are being calculated. Every time I could not go for an experimental study due to the availability of the specimen. So what I can do, I can create an FEM model, and based on the FEM model, what are the different forces it is being calculated, I can calculate using that. Next. Now, loads acting on the lumbar spine. If I am taking what are the different types of loads which is acting over the lumbar spine, that we can see. Lumbar, if I am taking the lumbar, produces hyperinflection and compressive loads at the facet joint. Suppose if this is going beyond the limit of bending, what will happen? These joints which I told you before, this facet will go for a compression load. That we should be careful. That is why this facet will go for a fracture. That is also is possible. Next case, this intervertebral disc, if I am taking one vertebrae and bottom there is a vertebrae, here there is a compression, here there is a tension. If a rotation is done in this manner, it will go for a compression at this point and tension at this point. Same thing, if I am going in this direction, here it will go for a tension and here it will go for a compression. So now what is the main thing we need to see here is, because the spine is a curvature structure that we need to understand. So generally if I am taking a vertical forces and the horizontal forces and the weight acting over there, I should able to know with respect to which the plane it is falling, and based on the plane only I can calculate the forces acting over here. For example, this vertebrae the force acting is different, for this vertebrae the force acting directions are different. So we need to be very careful while we are calculating these type of forces. And after that, loads, while we are taking the different loads, for example if you take this one, this example, see for example here 10 centimeter if it is apart, then what is the force it is generated? 20 centimeter. Here with respect to each point, what are the different types of forces are generated? Now this is the total. Like that we can understand what are the different type of compression loads and the different types of load it will take place in the spine. And while we are seeing the rotation, for example this vertebrae is rotating in this direction and this in different direction, at the time what is the stress level in the intervertebral disc? The reason is due to this intervertebral disc problem also they can face a failure of the disc. Now I am taking the load balance. Now for example, if I am taking as 100% as a load, in that case I want to explain you how the load is being shared in a spine. That is our major thing. Load, vertebra plus disc, this is called the vertebrae, this is the vertebrae. Vertebrae plus disc will carry the load around 55 to 60%. That is why I am dividing this into two halves. This I will call it as anterior side, this side I will call it as a posterior side. In the anterior side 80% of the load is being transferred, and in the posterior side only 20% of the load is being transferred. So this is for a healthy spine. We need to understand this for the healthy spine. Here it is around 10% of the load, here it is around 55 to 60, here 10. So totally it is around 80, and remaining 20 to 25 is carried in the facet and the remaining components. Now while we are seeing here vertebra plus disc, it is carrying around 55 to 60. Cortical shell, which I showed you, that is the outermost part of the board, that is called as a cortical. Cortical will be sharing around 10%, and posterior ligament. Ligament, if I am showing it here, this is the right place to show the ligament. This outside ligament is called anterior ligament, anterior longitudinal ligament. It will be from here to the entire spine, it will be there. This is called anterior longitudinal ligament, and here the ligament is called posterior ligament, posterior longitudinal ligament. This will called as ALL, PLL, and after that this is called supraspinous ligament, interspinous ligament, and in this facet it will call the capsule. Here also the ligaments will be there. So these are the different types of ligament. Ligament also will share the loads. And after that facet, it will take 20 to 25% of the load. Then only there will be uniform load transmitted in the outside part called annulus. If there is a change in the annulus, what it will happen means the annulus may go for a break. At the time the nucleus pulposus is a fluid material that can come out, that is what we will call it as disc degeneration. Here what is the main thing you want to understand? This blue structure is the spinal cord. That spinal cord is the one, it is directly connected to the brain. For example, what it will happen if the disc is degenerating and this will push over here. Due to the push over here, the blood flow will not be in a correct order. Because of that only the numbness will happen. For example, I showed in the first slide with respect to each which vertebrae concentrates which location. I shared it with you. Then isotropic stress profile need to be seen over there. And after that, ligament pull stresses away from the disc. What are the ligament? Here 10%, here 10%, like that. These are the for a healthy person, this is the way it will be seen. For example, the next case is for a degenerative. Suppose if the disc is going for a degeneration, which I told you before, 60% only the anterior side will take, and 40% will go for a go on the posterior side. The anterior only 68 will take. The reason is because of the disc failure, the disc will not move properly. So what we need to understand here means, if one disc is going for a failure, it will affect the remaining vertebrae of the body. Suppose L1 and L2 is going for a problem, remaining all the L3, L4 and L5 will get a problem. That we need to see it very clearly. So less efficient. So the degenerated disc will become less efficient. Vertebra plus disc will take a 40% load, cortical